95% of enterprise AI projects fail before reaching production. Most companies waste millions on AI that never works in the real world. But Netflix saves $1 billion yearly from AI recommendations. JPMorgan eliminated 360,000 hours of manual work. And HCA Healthcare saved 7,800 lives with AI systems. The difference? These companies understand enterprise AI requires completely different implementation strategies than consumer applications. I'm going to show you exactly why most enterprise AI implementations fail and the proven frameworks successful companies use to scale AI across their organizations. We'll examine real architectures from JPMorgan's 400 plus AI use cases to Netflix microservices serving 200 million users. By the end, you will understand 4-layer architecture framework, the 3 operating models, and the step-by-step roadmap that separates AI winners from the 95% who fail. In my upcoming apprentice book, Orchestrate, Mastering Multi-Agent AI in Business Automation, I dive deeper into these strategies and show you how to orchestrate multiple AI agents working together to automate entire business workflows. If you are new to this channel, please subscribe to our channel and press that bell icon. I share deep dives like this on SaaS, AI and product strategy every week. We also send a lot of free giveaways like ebooks, templates and worksheets to our subscribers regularly. Enterprise AI faces unique constraints. You are integrating with legacy systems from decades ago. You must follow strict regulations like GDPR and HIPAA. You need to support thousands of users while maintaining security and compliance. McKinsey found that 90% of AI failures happen because companies cannot operationalize AI in real business environments. They build models that work in labs but break when deployed at enterprise scale. MIT research reveals 4 distinct maturity stages with dramatically different business outcomes. Stage 1, experimenters, that is 28% of the companies. Performance 12.6 below industry average. These companies run random AI pilots with no systematic approach. Stage number 2, pilot builders, that is 34% of the companies. Still 3.5 points below average. They are trapped in endless proof of concepts that never scale because they lack production infrastructure. Stage number 3, AI workers, 31% of the companies. Performance 11.3 points above average. They have solved integration and workflow challenges. Stage number 4, AI ready, which is only 7% of the companies. Performance 17.1 points above average with AI native operations and new business models. The brutal reality, 62% of the companies never escape the first 2 stages. They burn cash on pilots that never deliver real business value. Let's examine how winners architect success. JPMorgan built their infinite AI platform within their Z ecosystem managing complete AI lifecycles. Their data mesh architecture uses product-specific data lakes cataloged through AWS S3 and AWS Glue. This enables parallel AI development across business units while maintaining governance. The technical foundation includes multi-cloud infrastructure strategically deployed across AWS, Google and Microsoft platforms with 75% of data and applications targeted for cloud by 2024. Results speak volumes. 400 plus AI use cases in production. More than 200,000 employees accessing AI daily. $220 million in annual benefits plus $100 million specifically at their commercial bank through AI-powered growth signals. Goldman Sachs took a centralized approach with their GSAI platform supporting multiple models simultaneously. Instead of generic solutions, they build bespoke AI tools for algorithmic trading processing massive data volumes in milliseconds, regulatory compliance with automated tracking, and investment research accelerating decision making. Their strategic investment include $200 million in AI chip maker Celebros and $72.5 million in machine learning platform H2O.ai, showing how they combine internal development with strategic partnerships. Netflix dominates AI at massive scale through microservices architecture. Their recommendation system breaks into independent services, user profiling, content analysis, model serving, A/B testing, each with well-defined APIs. They process terabytes daily through Apache Spark and Kafka streams, updating recommendations in near real time. Their monitoring includes sophisticated A/B testing frameworks where every change deploys to small user subsets first. Successful implementation follow a structured 4-layer approach. Layer number 1, business knowledge layer. Define KPIs aligned with business objectives. Establish baseline metrics from historical data to measure improvement. Most companies skip this foundational step and jump to technology, which explains their high failure rate. Layer number 2, data architecture layer. Create comprehensive semantic views linking organizational dataset. This includes data governance frameworks, quality standards, and centralized platforms. Shell built a global data platforms using data mesh approaches on Databricks, enabling secure data sharing across multiple departments. Layer number 3, application architecture layer. Structure AI-enabled applications through microservices, API management, and workflow orchestration, ensuring interoperability across systems. This layer handles integrations with legacy systems that often kill enterprise AI projects. Layer number 4, technology architecture layer. Provide computing environment supporting AI applications at scale, including cloud platforms, edge computing, security infrastructure, and DevOps optimized for AI workloads. 3 primary operating patterns emerge from successful implementations. Pattern number 1, centralized model. All AI expertise concentrated in one unit serving the enterprise. This provides efficient resource utilization and consistent quality, but creates bottlenecks and disconnection from business context. Second model, decentralized model. AI expertise distributed across business units with local control. This enables rapid response to business needs but leads to duplication and inconsistent standards. Third model is federated model, and that's the recommended one. This balances centralized governance with distributed execution. A central AI platform team manages guardrails, model risk management, and compliance, while business units drive specific use cases. Both JPMorgan and Goldman Sachs use federated models, central governance with distributed execution. This approach fosters innovation while maintaining enterprise oversight. Machine learning operations transform AI from research experiments into production business systems. Companies like Intuit reduce model deployment time from 6 months to 1 week using AWS SageMaker and automated DevOps practices, a 90% time reduction that directly impacts competitive advantage. Enterprise ML operation encompasses 5 critical components. First, version control for models and data. Track versions of datasets, code, and models meticulously. Each training run gets recorded for reproducibility. Tools like MLflow, DVC, and CloudML registries maintain history with metrics. Second, CI/CD pipeline for machine learning. Implement continuous integration deployment pipelines for machine learning models. When new model versions pass test, they automatically deploy through pipelines with approval gates. Third, testing and validation. Rigorous testing before and after deployment, including offline validation, shadow testing, and A/B testing in production. Netflix uses automated A/B testing frameworks comparing new model variants against business metrics. Fourth, deployment automation. Use containerization and orchestration to standardize deployments. Companies like Ecolab slashed model deployment timeline from 12 months to 30 to 90 days by automating infrastructure provisioning. And fifth, experiment tracking. Provide tools for data scientists to track experiments and collaborate. This addresses the reproducibility crisis, ensuring successful models can be recreated. Successful implementation follow a systematic three-phase approach. Phase number 1, foundation building, which takes 3 to 6 months. It assesses organizational AI readiness using established maturity models. Establish governance frameworks including ethical guidelines and risk management. Build data infrastructure with quality management and monitoring. Identify one high-impact use case with clear ROI potential and measurable success criteria. Second phase, which is pilot development, it takes 3 to 9 months. Execute targeted pilots with sophisticated success metrics beyond technical performance. Next, develop technical capabilities including ML operations, monitoring, and integration skills. Third, establish comprehensive evaluation frameworks tracking both operational and strategic value, and create change management strategies preparing users for AI-augmented workflows. Phase number 3, scale and optimize. That takes 6 to 18 months. Expand successful pilots across business units using systematic rollout processes. Implement enterprise-wide AI platforms supporting multiple use cases. Establish continuous improvement processes with automated monitoring and retraining. And measure and communicate business value using multi-dimensional ROI frameworks. Now, here are 5 patterns that consistently lead to failure. Pattern number 1, treating AI as isolated projects instead of integrated business capabilities requiring enterprise architecture thinking. Pattern number 2, focusing on technical metrics like model accuracy rather than business outcomes like revenue impact or cost reduction. Pattern number 3, insufficient data governance. Poor data quality kills AI faster than poor algorithms. Companies must invest in data infrastructure before model development. Number 4, lack of clear ROI measurement. Executives stop funding initiatives without demonstrated business value. Successful teams align AI projects with concrete business KPIs from day 1. Pattern number 5, over-reliance on internal development without strategic vendor partnerships. Leading companies combine internal capabilities with external expertise. BlackRock leverages their $11.6 trillion asset base, creating proprietary datasets that fuel superior AI models through their data flywheel effect. Tesla's AI-powered vehicles demonstrate 1 accident per 4.53 million miles versus 1.27 million for conventional vehicles. Walmart built 4 AI super agents: Sparky, Associate Agent, Supplier Agent, and Developer Agent, handling different retail operations while targeting 50% online sales. These companies aren't just improving efficiency, they are rebuilding competitive advantages around AI native architectures. General Electric achieved $7 billion in software sales through comprehensive AI integration, creating approximately 750,000 digital twin mirroring physical equipment performance. These stakes are existential. Companies mastering enterprise AI implementation create sustainable competitive moats, while those failing risk disruption by AI native competitors. So enterprise AI success requires architectural thinking, not just algorithmic powers. The 5% of companies succeeding understand that enterprise AI demands different strategies, organization structure, and technical approaches than consumer applications. 95% fail because they approach enterprise AI like building mobile apps. The winners know enterprise AI require systematic implementation of proven architectural patterns, careful attention to data infrastructure, sophisticated ML operation practices, and federated operating models balancing innovation with governance. Focus on building foundational capabilities that scale rather than impressive demonstration projects. The difference between pilot purgatory and production success lies in systematic implementation of the frameworks I have outlined today. Your next step is choosing your approach. Will you join the 95% burning money on failed pilots or implement the proven strategies that separate enterprise AI winners from the losers? What's your biggest enterprise AI implementation challenge? And drop it in the comments. I read everyone and use the best questions for future deep dives. Subscribe if this helped you understand why enterprise AI requires fundamentally different implementation strategies than consumer AIs. Thank you so much for watching. See you soon.